Okay, r prime, r, am I right? This is a kind of field point. Okay, test charge, the point where you are going to put the test charge, this is the field point. So this is your source charge to test charge, this is your italic r. So Coulombic force you can write as 1 by 4 pi epsilon naught q by r square into r cap, right? Force on this one due to this one, isn't it? Due to this one. If there is if any of the charge is negative, then what would happen? One more negative sign will come. It is along minus, sorry, the mistake. R square, r cap. Is that okay? If there is a if charges are opposite kind, obviously it will be minus r cap towards that one. Okay, it will take care. Okay, the formalism will take care. Separation, r italic r is the separation between them. Okay. Remember in the earlier problem I have placed the q here. Okay, let me come to that point. Okay, so that's a different story. Remember, when you place this source charge, test charge, okay, when you place the source charge here, your r prime vector will be 0. Okay, what is your italic r vector? R vector minus r prime vector. If you place your source charge at origin, r prime vector will be 0. Yes, speak out. So your italic r vector becomes r vector. Okay. Now, so again, before getting into that electric field, we shall quickly go through some problems here. Okay, I have equilateral triangle. I have equal charges at the corners of the equilateral triangle. What is the force on a test charge placed at the exact center of the equilateral triangle? Okay, I have a square. I have equal charges at the corners of the square. What is the force on the charge? I mean any charge. Okay, these are equal, either positive or negative. Okay, this also can be positive or negative. For a time sake, we shall take all are positive. Is that okay? So whatever. Okay, the result will be same. You can check it out. Okay. Now look at here. Now what is this one? If I take generally it's as a polygon. This is a triangle, square. Next one is pentagon. It's very difficult to draw. Am I right? Pentagon is very difficult to draw. So, but it's not regular, isn't it? It's a pentagon, but it's not regular pentagon. Is that okay? Approximately. Is that okay? Regular pentagon. I have equal charges at the vertices. What is the force on the charge at the center? What is the net force on the charge q at the center? So I have a hexagon. Regular hexagon. Regular means all sides are equal. Okay. I think he has given like that. Am I right? In the next problem, 13-sided regular polygon like that. Okay. A regular hexagon. I mean, very difficult to draw exact diagram. Okay, whatever. So Q, and Q. What is the force on the charge at the center? Similarly, for 12-sided polygon, that's our clock. Clock is the best idea, isn't it? Each charge is placed at the each number of the clock. Am I right? So then 13-sided polygon, isn't it? You better generalize that one. Okay, you can't. I mean, so for a even-sided polygon, you can have the idea. Now look at here. If I take this one, so this will this will what you call offer force like this. This will offer force like this. It is equidistant from these two. These two forces will get cancelled. Similarly, so forces due to this one will be cancelled by the force due to this one. Force due to this one will be cancelled by force due to this one. You can argue in this one also, isn't it? In a even-sided polygon, so can I say like that? It's very easy because you will get opposite charge in the exactly opposite side, which will cancel out the effect of one charge, isn't it? Now what about this one and this one? One charge will? Be careful. Be careful. Now look at here, due to this one, what is the force in this direction? Due to this one, what is the force in this direction? What is this angle? This is F and F. Force is same. Magnitude of the force is same. Why? These distances are same. Isn't it? So now let me take this distance as R. So can I take like this? This distance as R. My magnitude, I'm writing magnitude. I know the direction. Once I write the direction in a space, I'll not worry about x cap, y cap, z cap or something while writing. Is that okay? F is equal to 1 by 4 pi epsilon naught q by r square. Am I right? That is the magnitude. That is same here. So this also distance same r. Am I right? So now what is this angle? Any idea? You have to work it out, okay? Class 12th level problem. 120 degree, 60 degree, 30 degree, 30 degree, 120. 120 plus 60. Am I right? This should be 120, 120 degree. So two forces equal in magnitude, 120 degree in direction. Obviously, its resultant will be like this. Am I right? Two forces equal in magnitude. So can't you feel that your resultant will be exactly at the middle of this one? Isn't it? And what is the magnitude of that resultant? Look at here. So magnitude of the resultant, that's equal to root of f square plus f square. So plus 2ff cos of the angle between them. Am I right? 2f square cos 120 degree. Are you getting my point? Law of cosines. So vector addition of these two is a fr. Am I right? What is the magnitude? Root of f1 square plus f2 square. Just I have written a square plus b square minus 2 plus 2 a dot b, like that. Am I right? So that's the formula. Okay? Law of cosine. Now what is this one? Cos 120 is minus 1 by 2. Am I right? So minus 1 by 2. So that is root of f square plus f square minus f square. 1 minus 1 by 2. Okay? That's equal to f. This resultant is f again. F again. Okay? What is this one? This is the resultant of force due to these two. Now I have one more. This will offer the force in this direction. What is the magnitude of that force? F again. What is the net force? Speak out. Speak out. Don't you believe that vector algebra? Yeah, speak out. You collapsed to something. I mean, your mind collapsed to something. Wave function. Yeah, you are expecting resultant force, isn't it? 0. Check it out. Is that okay? So here also it is 0, but very difficult to show. Isn't it? Because you need to add, I think, yeah, very difficult. Here I can show. And I'm going to generalize. Yeah, speak out. If one of the charge is missing, then it may imbalance. Remember, if all charge is present, then it will cancel out. Look at here. If all charge is present in the hexagon, definitely it will cancel out. Yeah. Then there will definitely imbalance will happen. Am I right? Now let me talk about that one. All are present. Net charge at the center is 0. Whatever may be the polygon, there should be regular polygon. That's it. Even 13-sided, isn't it? So don't think of solving that 13-sided polygon, isn't it? You can't even draw that one, 13-sided polygon. So try that one. You can draw, it will not be regular. 12 o'clock you can argue, am I right? So charge at 12 will be, force due to charge at 12 will be cancelled out by, so 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, am I right? So charge at the center, force due to this charge will be cancelled by force due to this one, isn't it? You will get opposite one. For any even-sided polygon, this will happen. You can quickly argue those forces will get cancelled out and net force on the charge at the center is 0. Wait a second, we shall go to next problem little later. But next, see the next problem, 13-sided polygon. What will you do? Now I am too lazy to do that one. That's why I do that one for triangle. And I'm going to say the same thing will happen for pentagon. Same thing will happen for 7-sided polygon. What would you say? 7-sided polygon. Let it be. Okay? Yeah. Yeah, whatever. Now, again, so for 13-sided polygon, the same thing will happen. Very difficult to show even for this one, even for pentagon. Okay? You have to find the angles and you have to work out the force due to this one, force due to this one, and you have to see how they are going to get cancelled. Okay? Not that easy. But for any regular polygon, if you are placing same type of charge at each vertices, so force on the so the net force on the test charge placed at the center or net force on any charge placed at the center is 0. So whatever may be the nature of the charge, both of them may be negative, this may be negative, this may be positive, whatever, forces will get cancelled. You can check it out. Okay? So the only condition is all of these charge of same type, same magnitude. Okay? So that's the condition. So now part B of each question. Now again let me start with this one. Isn't it? Let me start with this one. Isn't it? So that I can answer, I can generalize again answer. Isn't it? Now look at here. So this was the net force due to these two charge. Am I right? These two charge offered net force in this direction. Now let me take, this is the missing charge. So then there will be no force in this direction. Am I right? Now look at here. This is the net force. The net force is magnitude of the net force is due to one charge. Magnitude of the net force is equal to magnitude of the force due to one charge, and the direction is towards missing charge. Is that okay? So now, similarly, I think if charges are opposite, what would happen? Ulta will happen. If charges are opposite, ulta will happen. Be careful, okay? So here he has taken positive charges. So while answering here, you have to be careful. So to say force is 0, any type of charge, okay? To say what will happen if one of the charge is missing in that regular polygon, so then you have to talk about whether they are positive or negative, okay? Be careful. Now I am taking all are positive. So now the net force is towards the missing charge. So whatever the missing charge I have taken here, you can just rotate, isn't it? So similarly here also, suppose this is absent. Look at here, force due to this one is balanced by force due to this one. Only this one present. Net force is due to magnitude of the net force is due to one charge. Force due to one charge, and direction is towards missing charge, and it will happen for all regular polygons. Is that okay? So 12-sided polygon also. Now, so 13-sided polygon. For 13-sided polygon also, if when one charge is missing, so the net force is due to one charge, and direction is towards the missing charge. Okay? Now wait a second. Let me write in this way. Let me take this one. Okay? Let me take this one. Let me take first charge, second charge, third charge, fourth charge, 5 charge. Okay, 5 charges. Okay? So now let me write the forces. Force on Q is equal to 0. Am I right? F1 plus F2 plus F3 plus F4 plus F5 is equal to 0. Am I right? Null vector. Force on Q. Net force on Q. Net force on Q. In this configuration, that's equal to 0. Obviously, you can write like this. Now look at here. If first charge is missing, obviously net force is non-zero, isn't it? If first charge is missing, what is the force? All charges present. If first charge is missing, What is the force on Q? F2 plus F3 plus F4 plus F5. But you don't have to find that one. Look at this equation. Look at this equation. F2 plus F3 plus F4 plus F5 is equal to minus F1. Isn't it? That's equal to minus F1. Look at here. That is opposite of force exerted by this one. What was the force exerted by first charge? This one. This was F1. Am I right? Minus F1 towards that missing charge. Is that okay? Mathematically, you can show that one. Yeah, do it yourself. Do this step yourself. One of them by minus Q. Then I think that will be doubled. Am I right? That will be doubled. That would happen. So, I mean, look at here. Yeah, I'll take these ideas later. Okay. We have Q here. Now, taking off this charge is equivalent to adding one minus Q charge. Minus Q plus Q net charge is 0 at that point. Okay, I'm going to take this idea later to solve some problem. Okay, so placing minus Q charge is nothing but adding minus 2Q to this one. Am I right? You can take those ideas always. Is that okay? Adding minus 2Q for those. Yeah. So you can have any type of problem. First, you better to start with there are charges at all corners. If one is missing, what would happen? That's better, isn't it? If there are all charges, you will get this equation. Quickly, you will get into this equation. Okay. Just see Griffith's solutions. Okay. Now, we shall not stop here. We shall find what is this net force. Suppose if we ask what is this net force, if A is the side of the polygon, then what would we do? Are you getting my point? If what is this net force, if one charge is missing, okay, if A is the side of the regular polygon, because your force is in terms of this R, am I right? 1 by 4 pi epsilon naught Q capital Q by R square, isn't it? Now you have to write this R in terms of A. How do you write? That is different in each case. Look at here. That is different in each case. This is R.